Now we'll talk about the bivariate distributions. Bivariate is that you have two random variables x and y. So you can draw it in a, say suppose you have x and there is x1, x2, x3, and then you have y and you have y1, y2, y3. So you want to know the probability of x1, y1, and then you can also have, so that's the probability of x1. So probability of joint y is equal to yj and x is equal to xi would be the joint probability distribution. But then there is something called the marginal probability distribution. Marginal probability is nothing but the value of x. So marginal probability of x would be x for all the values of y. So this is the probability of x is equal to x1 for all the values of, so this is the marginal probability of x. And this on the other hand is the value of y for all the values. Probability of y is equal to y1 is the marginal probability of y for all the values of x. Since these tables appear on the margins of the table, they are called as the marginal distributions. So joint distribution of x and y is given by f x y, that is probability of x is equal to little x and y is equal to little y, while the marginal distribution, let's just say it is called by g x, is the same. Instead of using the notation f, you're using the notation g, is the sum of all the values of y. It is still the same thing. Function xy is equal to probability of x is equal to x for all the values of y. We'll write it y here, and fxy for all the for all the all it's saying is the PMF of fxy, which is this here, for all the values of x, this one, this one, this one, for all the values of, or for g, it's going to be actually not this one, it's going to be this one. For all the values of y, this probability of xy for values of y, for this xn, y2, x1, y3, for x is equal to x, the x remains the same, and that gives you the marginal distribution of x. And the same way we call as h of y is going to be for all values of x, fxy, when probability of y is equal to little y. So this is the marginal distribution. So bivariate probability mass function for any random variable x that takes a set of values that you can list. The f of x is equal to probability of x is equal to x is it is called the PMF of x. For a pair of random variable fxy, probability of x is equal to x and y is equal to y is called the joint PMF of xy. So joint PMF of xy is just this: probability of x is equal to little x and y is equal to little y. That's the joint PMF of xy. Question: if x and y have a bivariate PMF, x and y have a bivariate PMF fxy is equal to x plus y upon 21, where x is equal to 1 and 2 and y is equal to 1, 2 and 3. What is marginal PMF of x. So marginal PMF of x is h of x if for sum of all the values of y, f of x y is equal to, we just sum it up for all the values of x for all the value, and what is the PMF of f of x is x plus y over 21. So all we have to do is we're going to do x plus 1 upon 21 plus x plus 2 upon 21 plus x plus 3 upon 21. That gives me 3x plus 6 over 21, or 3x plus 2 upon 21, or x plus 2 upon 7. Another question is, for a set of data values x1, another question is, for a set of data values x1, x2 and x3 or xn, the empirical distribution function, this is called the empirical is defined as a discrete distribution having probability of, empirical distribution function is a discrete distribution having probability of 1 upon n allocated to each of the data values. So f of x is 1 by n for x1, x2, xn, and 0 otherwise. Now we have data x1, x2, xn. These are just n values like heights of n people. And we want to select one of the data points at random and denote its value as x. Now this x can be viewed as a random variable taking the value of x1, x2, xn, each with a probability of 1 by n. The distribution of this random variable is called the empirical distribution. So we have n number of people, and each one person height, say height probability is 1 by n. Empirical CDF is given by probability of x is less than equal to t is f of t, which is the number of x1, x2, xn less than equal to t divided by n, and expected value of x is the average of data values, and variance of x is equal to variance of data values. So that is just a brief introduction on the empirical distribution function, where probability is 1 by n for each of the value x1, x2, and xn, and so the probability mass function, this is actually a value less than t, is a f of t, where if it is less than t, number of x1, x2, and xn less than t divided by n. An expected value is average of the data values, and variance is the variance of the data values. Okay, let's do another question. A coin is tossed 17 times. a coin is cost 17 times. There can be at most 16 pairs. There can be at most 16 pairs of consecutive heads. What is expected number of consecutive heads? Let the number of consecutive heads be a random variable. So let's try a different pen here. Try orange pen. So let the number of consecutive heads be a random variable x. Now we can try to calculate it as expected value of x 0 into probability of x is equal to 0 plus 1 into probability of x is equal to 1 plus all the way to 16 probability of x is equal to 16. But let's do it differently, because this is you can do it expected value, but let's try to do it differently, that x is a sum of 16 indicator variables, where indicator 1 is equal to 1 if there are consecutive head at position 1 and 2, and else it will be 0, and indicator variable 2 will be 1 if there are consecutive heads in position 2 and 3, else will be 0. Indicator variable 3, it will be an indicator variable, basically indicator variable 16 would be 1 if there is variable between 16 and 17, else it will be 0. Thus we can see that the x will be a sum of indicator variable 1, indicator variable 2, all the way to indicator variable c. Now what is the expected value of indicator variable 1? That is 1 times 1 by 4. Why 1 by 4? Because probability of getting h and h at a position 1 and 2 is going to be 1 by 2 times 1 by 2, that is going to be 1 by 4. Similarly, the expected value of I2 is all going to be 0.25, because the value is actually only 1 at each of the pairs. So expected value of all are going to be 0.25. So expected value of x then becomes expected value of 1 plus 2 all the way to 16, which is going to be 16 times 0.25. This is going to be 4. So this is the expected number of pairs of consecutive heads.